Taiwan, a small and highly populated country, has approximately 2.64 million hectares of slopeland, 3/4 of the island's land mass. So, the conservation of soil and water becomes a crucial link between the conservation of national land and the sustainable use of natural resources. To carry out tasks such as slopeland management, watershed management, and erosion control, the Soil and Water Conservation Bureau of the Council of Agriculture of the Executive Yuan applies multi-scale images and modern technologies of remote sensing to assist the management and the treatment of slopeland. Multi-scale images include spot satellite images, Formosat 2 images, airborne light detection and ranging (LIDAR) data, aerial photos, aerial images from helicopters, remotely piloted vehicle (RPVs), and so on. Satellite imagery exhibits the characteristics of lower cost, the ability of multispectral sensing, and the routine periodic updates, which are suitable for large area monitoring. On the other hand, aerial photography can be used to vividly capture Earth's surface and to calculate the disaster area and the cubic meter of Earth. Airborne light detection and ranging (LIDAR) uses laser scanners mounted on airplanes or helicopters to determine the distance between the sensor and the target through the usage of radio waves and the measurement of time delay between the transmission of waves and the detection of the reflected signals. This technology captures the height of Earth's surface and is helpful in the simulation of 3D terrain and the quantification of disasters. A remotely piloted vehicle has high mobility and the ability to carry out aerial surveys immediately after the disaster strikes, providing disaster information. Thus, it is suitable for the investigation of small areas. Below are actual cases of how the Soil and Water Conservation Bureau makes use of the above-mentioned technologies. The investigation of landslides. Slopelands in Taiwan are steep with broken rock strata, which are often vulnerable to sediment disasters brought by torrential rains in the typhoon and monsoon seasons. To investigate the area of landslide, the Soil and Water Conservation Bureau uses the reflectance spectrum of barren land obtained by satellite imagery minus the deterioration caused by human-induced disturbances to determine the conditions and changes of landslide. Periodical aerial survey for key reservoirs. To effectively monitor the landslide situation in the upstream areas of watersheds, the Soil and Water Conservation Bureau carries out periodical aerial photography in disaster-struck landslide areas. For instance, the Soil and Water Conservation Bureau performs periodical aerial photography over Shumen Reservoir and uses the aerial images along with a topography model obtained by LIDAR to estimate the size and cubic meter of landslide areas, offering valuable information for restoration purposes. (3D) aviation simulation in disaster areas. Real geographic environment can be better displayed through 3D demonstration. In combination with satellite images, aerial photos, and topography models, the SWCB utilizes computers to simulate aviation in unreachable areas. This helps the decision-making authorities to have a grasp on the current situation. Variation of satellite imagery. In consideration of the fact that slopeland violations inspection and reporting is often limited by issues such as peer pressure, short of staff, and heavy workload, the Soil and Water Conservation Bureau introduces remote sensing technologies to monitor the conditions of slope development. This method compares satellite images taken in earlier stage with images taken in later stage. An NDVI value is calculated to obtain the position of the variation. cadastral maps, road maps, and administrative division maps are used to analyze the correct position, allowing investigators to conduct on-site inspections. To avoid inspection mistakes, the staff in charge brings a GPS receiver and a PDA to report back the examination results, thereby significantly improving the efficiency of administration. Investigation for immediate disasters. When disasters occur, remotely piloted vehicles can arrive promptly at a disaster scene. Ground personnel then uses wireless receivers to transmit images captured by the vehicle to the screen on the ground, from which the ground personnel may perform aerial photography and hence obtain first-hand information on the disaster. Moreover, in combination with the topography model, SWCB can also estimate the cubic meter of Earth. Integration services for multi-images. Besides the continuous application of multi-scale remote sensing techniques on environmental monitoring, the Soil and Water Conservation Bureau utilizes the new grid computing technology to integrate all kinds of spatial environmental data under the service-oriented concept of SOA to provide disaster relief information for the central and local authorities. The Soil and Water Conservation Bureau will continue applying advanced technology in environmental monitoring and management to achieve the goal of slopeland conservation. The Soil and Water Conservation Bureau of the Council of Agriculture of Executive Yuan strives to work with you.